Here's some homework help for the problems, one of the problems anyway, on page 378. This is from lesson 6.1. And I picked one of the problems from that block of problems, the graphs that you have to do. There are 6 of them from problems 20 through 25. And I just wanted to show you how that the process that I'm going to show you with number 21 is really the same step-by-step process that you will follow when you do any of those graphs. Okay, so what I'm showing you with number 21 will apply. Just follow these steps in the same way that I'm doing number 21, and you should be able to successfully come up with the graph on the other 5. Okay, so the way I want you to think about these graphs is I want you to think about these as being transformations of a parent function. So that's going to be our step number 1, and I'll just kind of number our steps here and lead you to a final table that we will graph from. So step number 1 is pull the parent function out of all of this. So you got to be able to identify what is the parent when you're looking at this given function. And the parent is just that number that we call b if we're looking at the form. It's in this case, the fraction that is sitting directly below the exponent. So it's f of x equals the fraction 2/5, and for the parent it's very simply just raised to the x power. So if we want to identify the parent, just block this number out. Don't think about the -3 yet. Don't think about the -6. It's just a very basic function. F of x equals the number below the exponent, which is 2/5, raised to the x power. And we're going to make a table of values using this parent function. Okay, so inputs and outputs, and we can use those same inputs every time. We typically say if x is 0, 2/5 to the 0 is 1. If we let that exponent be 1, then obviously 2/5 to the first is 2/5. If we let the exponent be 2, then we're squaring this whole fraction, so you square both numbers. 2 squared is 4 over 5 squared, which is 25. And then we'll pick the opposites of these numbers. If we do -1, that means we're going to flip this 2/5 over, make it 5 halves, or you can, if you want to, you can think 2 1/2. And then if you do -2, then that flips this fraction over. Instead of 4/25 for +2, we get 25/4 for exponent -2. Or if you want to, since we're using decimals here, if you just plug that in your calculator, 25 divided by 4, you would get 6 1/4, or 6.25. Okay, so that's our starting point, and that's the same thing that you will do in these other problems surrounding number 21, is pull the parent out, do a table, and now let's work on, just one at a time, let's work on these other operations that are being performed on the parent. Alright, so maybe I'll just come over here and we'll do step 2. Alright, so we got our parent table, so we're going to build from that. Step 2 is I'm going to take care of this multiplying by 3. I'll just call this times 3. Alright, notice how it's 3 times the parent. Well, when we multiply by a number like this 3, we're going to look at our parent table and we're just going to multiply the y's. I'll put y's only. So looking at your parent table that you just made up, we're only going to multiply the y coordinates of the parent by this number, in this case 3. Alright, so let's see what that table looks like. Now I'm just going to write the x's down because at this point with step number 2 nothing is happening to these x's. So I'll just write those down. And now I'm going to multiply 3 times each of these y's. So 1 times 3 is 3. 2/5 times 3 is 6/5, which is 1 1/5, but we'll just leave it as 6/5 for now. 4/25 times 3 is 12/25. And if you need to use your calculator for this, that would be okay. 2.5 times 3 is 7.5. And 6.25 times 3, I believe that is 18.75. Okay, so far so good. So we got our initial parent function table. We took care of the multiplying by 3. That's called a dilation. And multiplying by 3 means we're going to take a parent graph, which is, this is exponential decay, and it magnifies it by a factor of 3, makes it larger. We call it vertical stretch. It stretches it upward by a factor of 3. Well, we've taken care of the multiplying by 3, and now let's do our third, and we'll do our final step. We'll just combine this really into one. I'm going to make another table, and now I'm going to base off of this table that we just created from step 2. I'm going to do the translation. That's just another word for a shift, and we're shifting in two different ways. If you remember from our past translations of like the square root function, let me just give you a little review here. This is a translation of the square root function, the square root parent, and we're going to shift it according to this 3 units to the right. Okay, remember that horizontal shifts are kind of tricky because you have to be careful to remember that it's opposite of the way it really looks. Well, that's exactly what this is telling us to do. We're going to shift our table that we just created from step number 2 3 units to the right. And the way that I accomplish that, I'll just call this table 3 units right. And let's just go ahead and take care of, while we're doing our description, this number in the function is saying we're going to shift 6 units down. Alright, so just again relating it to what we've done in the past. The square root function under the radical tells me left or right. Outside of the radical tells me up or down. And that's exactly what this does. So I'm calling this final table in step number 3, 3 units right and 6 units down. Alright, and here's how I accomplish that to come up with my final table that I will graph from. Okay, to accomplish 3 units to the right, I'm going to add 3 to each one of these x's. That's essentially another way of saying if I'm here at 0, 3 and I want to go 3 units to the right, that's like adding 3 to the x coordinate, making it, instead of 0, 3, I'm making it 3, 3. Okay, well that's what I'm going to do. I'm just going to take each one of these x coordinates and I'm going to add 3 to them one at a time. 0 plus 3, 1 plus 3, 2 plus 3, negative 1 plus 3, negative 2 plus 3. Alright, and now let's do the 6 units down. And the way I'm going to do that is I'm going to take each one of these y coordinates and I'm going to subtract 6 from them one at a time. 3 minus 6. This is 1.5, and if you need to grab your calculator for that, that would be okay. So we'll just make my screen a little bit smaller and we'll just pull up our calculator. And let's see, what was that decimal again? 6/5. 6/5 is 1 1/5, which is 1.2 minus 6. That's negative 4.8. Alright, 12 25ths. Let's get our calculator and we're going to do 12 25ths minus 6. So 12 25ths. And then we'll do minus 6 from that. Try that again. Okay, and then minus 6, negative 5.52. All right, so here we have 7.5 minus 6, that's 1.5. And 18.75 minus 6 is 12.75. And we have our final table, and I'll circle this table because this is the table that we're actually going to plot the points for, connect the dots, and we will have our final graph. All right, so I'm not going to bother changing the units. You probably don't have as many lines for graphing on your y-axis as I do. If you wanted to change yours into 2s, maybe I'll just go ahead and do that. So you'll probably have to do that, so I'll do the same thing. So I'm doing my y-axis in units of 2. I'm not going to change the x-axis. Okay, so 3, negative 3. Here's 3, and negative 3 would be about right there, about halfway. This is negative 2, and then another 1. Probably pull that up just a little bit. All right, 4, and then negative 4.8. 2, 4, just about negative 5. We'll guesstimate that to be about right there. And then 5. And negative 5 or really negative 5.5. So 1, 2, 3, 4, 5, 2, 4, just a little bit below this one. Just a smidge below the one to the left. All right, now we got 2, 1.5. So we'll put that about right there. Again, these are guesstimates, but we're in the neighborhood. And then we've got 1, 12.75. So 2, 4, 6, 8, 10, 12. We'll just put it about right there. And now we're ready to connect the dots and draw our graph. And that's not always easy for me to do with this, but yeah, that's not too bad. Now, if you'll notice, I am approaching, since we went down 6, and since I'm in units of 2s, this is negative 2, negative 4, here's negative 6. My graph should never go below y equals negative 6. That's the line that I'm going to be approaching forever. It's called a horizontal asymptote. I'm going to be approaching that line, but I will never touch it. So if you draw your graph so that it goes way down below y equals negative 6, then that would be incorrect. So we need to be approaching negative 6 but never touching. All right, and so that's the completed graph, and these are the steps you follow. Find the parent graph or table. You don't really have to graph anything, just work with that table. And then if you have something multiplied in front, like we did here, multiply times the y coordinates only from the parent table. And then take care of your translations. Now remember, if this had said plus 3, that means I would have subtracted 3 from every one of the x's, because that's a left move. If this had said plus 6, that means I'm shifting 6 places up, which means I would have added 6 to all of the y's. But in this case, you just basically followed, this is a shift of 3 to the right and 6 down, and so we took care of the xy coordinates appropriately. So I hope that helps, and if you have any questions, feel free to let me know, but I think hopefully this will help you with the other 5 graphs in that block of problems.